Random number functions and random sampling. SAS has a number of functions that generate random numbers based on specific distributions. For example, the SAS function ranUni generates uniform random numbers ranging from 0 to 1. So when you use the ranUni function, any number between 0 and 1 is equally likely to be generated. The way the function works is that it requires an initial number or a seed which generates the first random number. The function then uses subsequent random numbers to generate the random numbers after that. So for example, here we have a variable num equals ranUni of 1, 2, 3. So 1, 2, 3 is our seed, and num is going to have some numeric value between 0 and 1. Here's a simple program that uses this random number function. So here we're creating a data set called 1, and we're going to iterate through this data step 5 times and create a variable num, which is equal to ranUni of 1, 2, 3. So that's our seed, and we have an output statement so that each time SAS iterates through the loop, it's going to output an observation. And so you see we have a printout of our 5 observations, which are a list of random numbers, and each number is between 0 and 1. If we were to run this exact program again using the seed of 1, 2, 3, then the same list of numbers would be generated. To get a different list of numbers, you would need to put in a different seed in the ranUni function. If you put in as a seed the value of 0, then SAS would use the clock time as the seed. So if you put 0 in as the seed, then SAS will generate a different list of numbers every single time you ran this program, because 0 tells SAS to use the clock time, and the clock time is always changing. You would always get a different list of random numbers generated from this program if 0 was used as your seed instead of 1, 2, 3. The random number function can be used in programs to generate random samples from your data. And we are going to look at how we can use the random number function to generate random samples in the SAS demonstration video. There will be occasions when you want to make use of simple random sampling in your research. First of all, if you're analyzing a very large data file, it's easier to work with a simple random sample than with the large data file. It doesn't take up as much computation time. You can test out programs on a smaller sample, and then once those programs work, you can apply them to your larger data files. Also, you can draw a simple random sample with replacement from a small data file. And lastly, something that I do quite often is randomize patients to treatment groups when I am involved in a clinical trial that requires having patients receive a treatment and patients receive a control. Your Cody and Smith textbook gives useful SAS code for how to randomize patients to treatment groups. A SAS utility procedure that we will make use of in the SAS demonstration of random sampling is PROC rank. So PROC rank is used to divide observations into equal size categories based on the values of a variable. And within PROC rank, you can create a new variable containing the categories. And the new variable is then added to the data set or to a new data set. And so one way that PROC rank is helpful is when you need to divide patients equally into 2 treatment groups. But more generally, when investigating the relationship of a continuous independent variable to a dependent variable, it is often desirable to divide the independent variable into categories and then see how the dependent variable changes across the categories. So let's suppose you want to investigate the relationship between change in weight and change in blood cholesterol. One analysis you could do is divide people into categories based on their weight change and compare the average cholesterol change across the weight change groups. Suppose you may have specific weight change categories of interest. For example, weight loss greater than 10 pounds, weight loss 1 to 10 pounds, weight gain 1 to 10 pounds, and weight gain greater than 10 pounds. However, in some cases, you have no pre-specified categories. Then you may just want to divide persons into categories of equal size. To do this, you could run PROC univariate on weight change, look at the quantiles to determine the cutoff levels, and then go back and create new variables using if-then logic. However, PROC rank can do that for you automatically. You simply tell SAS the name of the variable you want to form groups for and how many levels you want. PROC rank will then compute a new variable containing the categories and add it to the data set. PROC rank is a very efficient way of creating a new categorical variable from a continuous variable where you have equal numbers of subjects in each group. So here is the syntax for PROC rank. Data is the input data set. The out option is the output data set that will contain the new variable or variables. Since this data set will also include all variables in the original data set, you can usually specify the out data set to be the same as the input data set specified in data. And I would do that only when you're working with temporary data sets. Groups is set to the number of categories you want to divide the variables into. So for example, group equals 5 would create quintiles. With the var statement, you list the continuous variable for which you want to create new categorical variables for. And the rank statement lists the names you want to call the new variables. Since PROC rank is just creating a data set, no output will go to the output window. With the PROC rank syntax, if you leave out group, then PROC rank is going to produce a new variable that's the rank of your old variable. So here is an example of PROC rank where we're not including groups in the PROC rank procedure. So we're creating a data set called age, and what we're interested in doing is just creating a variable called age rank. So we're not interested in regrouping age, we're just interested in ranking age. We've left out the groups equal option in our PROC rank statement. And so if you look at this output box, here we see a printout of the age and then the rank of age in our data set. So the age of 28 would be the second smallest value of age in our data set. 17 has a rank of 1, which is the smallest age in this data set. In this second example, I've included the groups equals option, and I've set groups equal to 2. So using PROC rank, we've created a new variable age group which divides the subjects into 2 groups. And if we were to do a PROC freak of age group, we would see that we have an equal number of observations with the value of 0 for age group and an equal number with the value of 1 for age group. In the SAS demonstration video, where we're taking a random sample, we will use PROC rank to create equal number of patients going into a treatment group and an equal number going into a control group. PROC SURVEYSELECT is a very straightforward method to draw a simple random sample. So besides just using random number functions to take a simple random sample, we will also look at the procedure SURVEYSELECT and how we can use that to draw a simple random sample. And this procedure allows sampling with and without replacement. When you do your project, you will be using PROC SURVEYSELECT. Each of you will take a simple random sample of a large data set that I provide. So each of you will have a unique data set to analyze for your project. Now view the SAS demonstration programs, random number, and SURVEYSELECT.